Hi, this is Prasanna from Wave Academia. In this video, we are going to see how to simulate buck boost converter model using Matlab. So buck boost is another type of DC-DC converter which will either increase the output voltage or reduce the output voltage based on the duty value. So this converter will do both the buck action as well as boost action. Let us see how to simulate the buck boost model with the help of Matlab. Straight away, I'm going to the Matlab. I just opened the Matlab Simulink page. If you want to develop the buck boost converter, I will tell you what are all the elements required to develop the model. I'm going to library browser. I'm going to Simscape. In that, I'm going to electrical. I'm going to specialized power systems. I'm going to sources. I'll take DC input voltage. I'm adding to the block, adding to my model. I'm going to power electronics. I need a diode. I need a switch, IGBT bar diode as a switch. I need a inductor, capacitor as well as load resistor. So I'm going to passives. I'll choose series RLC branch. I need 3 number. I'm closing the library browser. First I will arrange the elements accordingly, according to the circuit. If you look at this, so in this diode, anode is there, cathode is there, and one more terminal called M port is there. Here I'm not going to use this M port. The purpose of M port is if you want to measure the diode voltage or diode current, you can use this M port with the help of bus selector. As of now, I'm not going to use this M port. Double click it, disable the M port. Similarly, if you take switch, here collector terminal is there, emitter terminal, gate terminal is there, one more M is there, that is for measurement port. I'm going to disable this one. I don't want the M port. So this switch is having 3 terminals: collector, emitter and gate. Similarly, this diode is having 2 terminal, anode and cathode. Okay, first I will connect the switches accordingly, connect the circuit accordingly. Here I need only one inductor. I need a capacitor alone. I need an inductor alone. Sorry, I need a resistor alone here. This one is my input voltage. So here in buck boost converter, switch will come at the input side, whereas the inductor will come at the middle and diode will come at the output side. And one more important point here, I'm going to reverse the connection of diode. In such a manner, the circuit will work. Now the basic circuit is completed. If you want to measure the input voltage and output voltage, because actually I want to compare, I need a voltage measurement. Similarly here, and I want to compare, so I need a scope with two input terminals. Make it as 2. Okay, before connecting, I want to tell you one important thing regarding this buck boost converter. If you look at the input output relationship of buck boost converter, I will write it here. Output voltage is equal to minus V in, that is minus of negative of input voltage into duty value d divided by 1 minus t. So this is the relationship which relates the input and output voltage of buck boost converter. So here this minus negative term will come into picture. If you want to see the output voltage, to avoid that negative term, I am going to use the absolute component. Actually, I want only the absolute of output voltage. So now our input is directly connected here. In between that, I'm going to in between the output and the scope, I'm going to connect this absolute term to avoid that negative signal. Okay, so this is as per the equation, as per the design. Output voltage is negative of input voltage into d divided by 1 minus t. Okay, so this is one important thing you have to do in buck boost converter. This is not required in buck converter as well as boost converter. Okay, fine. How this buck boost this circuit will work either in buck mode or boost mode. It depends on the duty value. Okay, if the duty value is greater than 50 percentage, it will work in boost mode. If the duty value is lesser than 50 percentage, then it will work in buck mode. Okay, keep it in mind. If the duty value is greater than 50 percentage, this circuit will work in boost mode, whereas if the duty value is lesser than 50 percentage, it will work in buck mode. Let us see how to do that. Here I am going to use a pulse generator. I am just connecting it here. So before that, I want to change the scope background. I'm going to view, I'm going to style, figure color as white, axis color as white, this pen is black. See, first channel 1 is actually it's nothing but my input. I can say that it's a black color, and channel 2 is my output. I want to fix it as it's a blue color. Okay, and moreover, if you want to add legend, you can add the legend. Okay, it will come later. Now, so as of now, first I will fix the values. Input voltage, I'm going to use 20. So if it is a boost converter, definitely the output voltage is higher than this 20. If it is a buck converter, definitely the output voltage is lower than this 20 volts. Let us see. Click OK. The inductor value I'm going to use is 47 millihenry, 47 e power minus 3. And the capacitor value I'm going to use is 100 microfarad. that is 100 e power minus 6, and the resistor value I'm going to use is 100 ohms. Okay, fine. And in pulse generator, first I will fix, let it be period is here 2 e power minus 5. Actually, this 2 e power minus 5 indirectly mentioned the switching frequency. We know that F is equal to 1 by 2. It's a famous formula which relates frequency and time. So this time period is nothing but 2 e power minus 5. So now what is the frequency? That is nothing but 1 divided by 2 e power minus 5, which comes around 50,000 hertz. So my switching frequency is 50 kilohertz. As of now, I'm going to consider my pulse width is 70%. That means D is greater than 50%. Definitely this circuit will work in boost mode. Now the pulse width is 70%. Keep it in mind. I'm applying it. Once you run the program, yeah, I need a power guide. It's mandatory. Whenever you are using a SimScape, power guide is mandatory. Without that, it will throws you error. So definitely this circuit will work in boost mode. Okay. This is your input voltage. Say it is 20 volts, and this is my output voltage. Now the circuit is working in boost mode. The duty value is 70%. Okay. Now I'm stopping the simulation. If you want to change the input name, you can change it here. Black one is input voltage. And the blue one is output voltage. Okay. So now I'm going to the pulse generator. If you change the pulse width, which is lesser than 50%, say it is 35% lesser than 50, definitely this circuit will work in buck mode. If you look at the output, the black one is your input, whereas the blue one is your output. So now the duty value is actually 35%. 35% of duty value. So it's working in buck mode. Output voltage is lesser than the input voltage. Okay, let me stop the simulation. Hope the buck boost converter operation is cleared now. So it depends on the duty value. If the duty value is greater than 50%, this circuit will work in boost mode, whereas when the duty value is lesser than 50%, this circuit will work in buck mode. And this is the input and output relationship of buck boost converter. I can say that the output voltage is equal to minus V in into duty divided by 1 minus t. Okay. So here one important thing in practical, you should not you should not take your d value either 0 or 1. Okay. Suppose if the d value is 0, it's literally meaning that you are instructing the switch to be always in off state. If the d value is 1, you are literally meaning that you are instructing the switch to be always in on state. Both will affect this circuit. So you should not reach either 0, you should not reach 1 as well as 0. That is, you should be very careful about the values. Okay. So to overcome this negative signal, here the absolute is using. Absolute will give you always whether the input is positive or negative, whatever it is, the output of absolute will always a positive. Hope this video will be helpful to you to develop the buck boost converter model. So in the upcoming videos, we'll see how to do closed loop buck boost model. Thank you for watching. Kindly subscribe the channel. Thank you.